What's going on, everybody? This is Mr. Dickin, and in this video we are going to be solving quadratics that have complex solutions. Remember, the word complex indicates that we're probably going to have imaginary unit values, and that stems from taking the square root of a negative number. All right, so we're going to be solving quadratics like we've done towards the beginning of this unit. We've got a handful of different methods. We've got taking square roots. We've got completing the square. We've got quadratic formula. All of those can be used now with the possibility of maybe having an imaginary result. So now, whenever we're solving quadratics, we're really finding the x-intercepts. And if our result gives us an imaginary result, well, that means that there are no x-intercepts. So a quadratic parabola that never hits the x-axis. All right, so let's get started. On each one of these little subsets, there are 4 examples. I feel like if we do 2 from each, we should be good to go. You'll have access to the PDFs of these. If you need to see more examples, those will be available to you. So for problem set 1, let's do numbers 2 and 3 will be good ones. We're going to be solving quadratics by using square roots. So let's take a look at number 2. Right here on number 2, I've got a squared, and my variable is trapped within that parenthesis chunk that's being squared. So ultimately, I want to be able to take the square root of that. However, I can't just do that right away because I've got this negative 2 out front. That's got to go. So I have to get rid of that negative 2. So first things first, I'll divide the negative 2 to the other side. And now I've got 3x plus 7 quantity squared equals, that'd be a positive 49. From here, to get rid of the squared, I'll take the square root of each side. That results in 3x plus 7 equals, the square root of 49 is both a positive or a negative 7. Since I've initiated that square root, I have to account for the fact that there are 2 potential answers. Now you'll notice for this one that I'm not even getting a negative underneath the radical, so no need for that letter I. All right, so let's go ahead and solve. We've got 3x plus 7 equals positive 7. We've got 3x plus 7 equals negative 7. On both of these, we'll move the 7 over to the other side, so subtract that over. And I get x is 0 for one of them. And if I subtract 7 over here, looks like we're going to get a fraction. X is negative 14/3. All right, so that one didn't result in an imaginary value. Go us. Next one, number 3. We got 4x squared plus 16. Again, we want to solve by taking the square roots of this x squared. So the 16 is going to have to go. That pesky 4 has to go. Let's first start off by getting rid of the 16. Throw that to the other side. So 4x squared equals negative 16. Now we'll divide out this 4 from each side. And now I've got x squared equals negative 4. To get rid of a radical, get rid of a squared, we'll take the square root. Anytime I initiate a square root, I need to have a plus or minus. So we'll get x squared equals positive or negative. Let's see, square root of negative 4 would be a 2i. Just as a reminder, imaginary roots, these guys, will always come in pairs because they're the result of taking a square root. All right, next method, we've got completing the square. Again, we'll do 2 of these. We'll do 3 and 4. And then we'll get into quadratic formula and we'll call it a day. So number 3, we've got x squared minus 4x plus 9 equals 0. Our goal here is to make sure that the x squared does not have a coefficient attached, which it doesn't, and then kick the c value to the other side. So now what we need to do is figure out what number could go here in this blank space so that the left side of my equation could be written as a perfect square trinomial. And the way we do that is we take half of our b value and then square it. So half of -4 is -2, square that is +4. Whatever gets added to one side must get added to the other to maintain balance. So now on the right side I've got -9 plus 4, that is a -5. So here's the equation now that I need to solve. X minus 2 quantity squared equals -5, square root each side. I've got x minus 2 equals plus or minus I rad 5. Therefore, x equals 2 plus or minus I rad 5. All right, one more completing the square example. Got 3x squared plus 6x equals 15. Some of you might be a little uneasy because, hey, we've got a coefficient here on the x squared. We don't like that when we're doing completing the square, not to worry. Let's just divide everything by that coefficient. When you do this, sometimes fractions might pop up. That's okay, fractions are numbers too. We just don't want a coefficient on the x squared. So we'll get x squared plus 2x, blank space, equals 5, followed by a blank space. So again, we want to figure out what goes into that blank space next to the 2. That would give us permission to write the left side as a perfect square trinomial down in factored form. So we take half of the b value and we square it. That would be +1 for both scenarios. So I've got x plus 1, quantity squared equals 1. And you know the drill from here, square root each side. X plus 1 equals plus or minus 1. Therefore, x equals, we'd have 0, or x equals -2. So again, completing the square still works the same way. You might get an I along the way now. It's the only difference. Quadratic formula. Let's do one of these. You guys are pretty solid with quadratic formula. You typically don't have too much issue with that. In case you've somehow forgotten, quadratic formula is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. For most of you, this tends to be your default. Now, the quadratic formula, we have a discriminant underneath the radical. This will tell us immediately if we're going to have an imaginary solution or a real solution, whether that's positive or 0 or negative. So let's go ahead, we'll do number 1, and we'll call it a day. So this is already written in standard form. ax squared plus bx plus c equals 0. So let's take the opposite of b, -5, plus or minus the square root of b squared, so 5 squared, minus 4ac, all of that over 2a. So now we need to make this thing pretty. This would be -5 plus or minus the square root of 25 minus, let's see, 4 times 3 is 12 times 4 is 48. So 25 minus 48 all over 6. And I can already tell my discriminant, the number underneath the radical, it's going to be a negative number. So I'm going to have an imaginary solution of some sort. Let's continue to whittle this down. -5 plus or minus, let's see, 25 minus 48. Holy smokes, what is that? -23. All over 6. And we don't like leaving negatives underneath the radical, so we'll clean this up just a smidge. -5 plus or minus I rad 23 all over 6. And we are done with that problem. All right, so that's how we solve quadratics that may or may not have imaginary solutions. These are all methods you've seen before, taking square roots, completing the square, quadratic formula. But if you ever see a negative value underneath the radical, just be aware that the letter I, the imaginary unit, will make an appearance. You'll notice the only method we did not use for solving and getting complex variables or complex results was factoring. If you have a quadratic that can be factored, and again, factoring is breaking it apart into its linear components. So this is just a made-up example. If it's possible to be factored, then you've already guaranteed that your answers would be rational numbers. If it's a rational number, it's guaranteed that it's a real number. If it's a real number, there's no imaginary component. So that is the only solving method that does not pertain to this. You know the drill. If you have any questions, let me know. And as always, good luck, have fun, be safe, roll tide.